Aloha, here we go. Today's AP review is rates and integrate. So we're going to deal with some rates, you guys. These are really popular questions as well. Remember, that's what we're focusing on when we're on these grind days. All right, so here we go. Rates and integrate. Okay, question one. Remember that year up there in the corner means 2018. We may have done some of these in class. If we did, then your job right now is to hit pause and see how far you can get on your own. All right, but here we go. Let's look at A and B. And this is number one, so that means it will be a calculator question. So we have people in line for an escalator, okay, and it's modeled by the following rate. Between 0 and 300 seconds, it's this rate up here. And then after 300 seconds, nobody else is getting in line anymore, okay? R of T is measured in people per second. T is measured in seconds. As people get on the escalator, they exit the line at a rate of 0.7 people per second or person per second. There are 20 people in line at time t equals 0, right? So that means that's our initial condition, and that's going to come into play. All right, A, how many people? So the total amount of people. And remember, whenever we get an answer, and whenever we're trying to find an answer of the total amount of people, then that means we're going to take the antiderivative of a rate, right? That's going to give me the total amount. So for this here, it's just the total amount of people that enter the line from 0 to 300. So this dude is simply from 0 to 300 of R of T dt. Remember, when doing this question, and I'm just going to leave it up to you guys to be doing this in your calculator and bring your questions in class before school, after school, when you need some extra help. But that guy is simply just plug and chug. And if you do that correctly, you get an answer of 270. If you did that correctly on your own, you got not only a point for setting up the integral, you got a point for the answer. Okay? And that would be 2 points so far for this question. Nice. On to that 4 and 5. All right, part B. Part B says during the time interval from 0 to 300, there are always people in line for the escalator. How many people are in line at time 300? Whoa. Now I have to account for everything. I've got to account for the people that were in line to start, right? Plus, I need to know now the total amount of people in line, but there's people getting off too. So I got to set something up for the first 300 seconds that stands for the total amount, which would mean integral, which means antiderivative of a rate from 0 to 300 of the total amount of people that get in line minus a rate of people leaving. And it says here it's 0.7 person per second. Now, don't get fancy with this. If it just says 0.7, I just got to do 0.7 because that is a rate. So if I do that, that gets me an answer of 80. So that means at the end of 300 seconds, there are going to be 80 people that are in line for that escalator, okay? And that's accounting for the total amount of people in, the people leaving, and the 20 the 20 that were there even before this problem started. All right, looking at my little grading over here, you could be 4 of 4 if you were able to get those pieces correct. All right, now let's go to C. It says for time greater than 300. Remember, greater than 300, nobody's getting in line. We just got people leaving. Get off, yo. Get to that store, right? What is the first time T that there are no people in line? Well, after 300 seconds from part B, there were 80 people still in line. So when are there no people in line anymore? Well, let's associate this with people leaving. Remember, people leave at a rate of 0.7. So 0.7 times time would give me people, right? 0.7 is person per second, T is second. So if I do 0.7 person per second times second, that's going to give me the total amount of people, which would be 80. So I'm going to set it equal to 80. And if I solve that, I get 114.285. Now you just got to be careful. That's how long it takes to get rid of those 80. Get rid of them. Okay, so you just have to be careful. And this one's only worth a point, but it would be 300 because 300 seconds has already elapsed plus 114.285. So it's 414.285. That's how many seconds it would be until nobody's in line and we're finally chilling at the mall. All right, part D, which is the most important piece, right? It brings up this piece called minimum. And we all know whenever we have a extreme, a minimum or a maximum, we've got to find a derivative, right? So this is where we have rates and integrals all kind of interconnected, okay? And it says from 0 to 300, when do I want to go to the mall? When are there the least amount of people in line? Well, I got to create a function. All right, I'm going to make it called n of t, number of people in line. And I want that to be a minimum. So I'm going to have to take a derivative of this. But first, I'm going to make it stand for just the number of people in line. And the number of people in line will be 20, because remember, there's always 20 in line to start before we start this problem, plus the number of people that enter, ooh, and that's r. But since I used a t here, I'm just going to use an x minus the amount of people that leave. And it's going to go from 0 to t, because what is that t that is going to give me the smallest number of people? Now remember, we said it earlier. To find a min, max, extrema, we're going to take a derivative. So let's go ahead and take a derivative of this bad boy right here. If I take the derivative of 20, that would be 0. Now this is the important part of these problems here. We're going to take the derivative of an antiderivative. And remember, the derivative of an antiderivative, we got a shortcut, and that is we just take a variable and we plug it in wherever the other variable is. Is that it? But we've got to make sure we change. So it's going to be r of t. Derivative of t is 1 ichiban, so nothing really happens, minus 0.7. That's it. And remember, 0 is a constant, so it's going to zero itself out. Remember, come in for help if you kind of forget that derivative of an antiderivative. Now, we all know when we find mixes, maxes, and mins and extrema, we have to find critical points. So we have to set that equal to 0. So what you guys have to do right now, and make sure you pause this and you do it. Okay, I need to know when r of t is equal to 0.7, because when it is, that would be a critical point, okay, because that is when the derivative would be 0. So what I should do is plug that into my calculator. Make sure I've got a window that goes from 0 to 300. Okay, make sure you plug your y2 to be 0.7. And I need to find out where they intersect. And guess what? They intersect at t equals, I got my answers here, 3.803. We're going to call that time 1 because there's 2 times. And my second time is 158.070. Now remember, I know I'm not going over it with this video because we want this to be nice and easy Japanese, and we should be okay with this by now if you're not come in. Stow that in alpha A, stow that in alpha B. Because remember, all of these questions, when everything is all said and done, will ask you to justify. And the way we justify, remember, is we make a table. We got our time and we have our number of people. And I want to find out when I have the least amount of people in there. Shame on me. I put the answers down here for these, you guys. When you plug that in your calculator, hope you're like, I wasn't getting that, Mr. T. This is 33.013298. Store that in alpha A. And this guy here is 166.574719. And let's store that in alpha B. All right. The ring around the rosy posy. Man, it's hard when you're doing it in a camera. All right, so what do I do now? Well, I check my endpoints 0 and 300, and I check my alpha A and alpha B. And remember, what do I do to get those? Well, I plug all 4 of those values in for this. So it's 20 plus, and then you're just going to math 9 it. And you're going to go to 0 to each one of these guys, which will give me 20. This is the 3.803. This is the 158 people in line. No, thank you. That is a max, though. How about it? I got the min and max when I did this, and this is 80. So the answer to the question is at 33.013798 seconds, all right, or 298 seconds. And the minimum people would be 4. There'll be 4 people in line out there. All right, so that's 2018. Okay, let's go ahead and see if a similar type of question was on the 2017 test. And if it was, how about it? Here we go. 2017. So they had this on 2018, they had it on 2017, which means this stuff is important, right? Big time important. All right, here we go. Number 2, we're talking about bananas. All right, we got bananas on a display table. And it says that customers remove the bananas at this rate. So they remove, I don't know about you, but I would say let R of t equals f of t. I like it when my variables relate. So that would be remove. And then this one here, we have employees that add to the display table. I'm going to call this let a of t equal g of t. I just like it when it's like that so that I know what I'm talking about. So we have remove and we have add, right, to our situation. All right, so let's go ahead and look at this. It says, how many pounds of bananas are removed from the, so just removed for the first 2 hours. So that's just 0 to remove. See, that's why I like the R of t, which is actually f of t. I'll do it like their grading was. So I just do that and put it in my calculator, and I write this as my answer. Remember, you round or truncate. It does have a trig function, which means you better be in radian mode, but that got me 2 points. That got me 2 points. I like it. I like it a lot. That's not too bad, right? Okay, now here, part B, it gets a little tricky. Every year, students really miss this one because it says, what's f prime of 7? Well, f is already a rate, right? That is, what does it say here? It says that's pounds per hour. That's what f is. So if I take the derivative, so all you have to do for this one is math 8. You just have to math 8 and plug a 7 in. And if you math 8 and plug a 7 in, you get negative 8.120 or negative 8.119, depending on you if you round or you truncate. But the important thing here is they ask you to, using correct units, explain the meaning. Well, if f of t is already a rate, which is pounds per hour, this will be pounds per hour per hour. And yes, class, you may say pounds per hour squared, but that takes care of it. Now, I got to make sure I explain it in context, so pay attention. I'm going to read it out. You guys write it down. It's after the store has opened, okay, and it's been open for how many hours? 7 hours. So after 7 hours, it is the rate, because remember, derivative means rate, but it's the rate at which bananas are being removed from the display table is decreasing, right? Okay, so remember this. This is already a rate. Okay, when I take that derivative, I am going to be talking about the rate. And since the derivative was negative, I say that the rate is decreasing. Okay, that means less people, right? Taking bananas off of there. So that's very important. A lot of students get it incorrect, but it is that the rate, because f of t is a rate already, but the rate, and it's decreasing. And it's decreasing by negative 8.120 pounds per hour. And you have to make sure you specify 7 hours after we have opened. Okay? It's important to say what that 7 was about. All right, C and D, obviously the bigger parts is the number of pounds of bananas on the display table increasing or decreasing. So now we're just talking about the bananas on the display table, which means I've got to account for removing and adding. Okay, so how would I do this? Okay, and it's asking just if it's increasing or decreasing. Now this one's a little bit different from part B, found the derivative, right, which talked about just the rate. I just want to talk. This is the number of bananas. So if I'm asking about the number of bananas, and I want to know if it's increasing, decreasing, I'm going to take the derivative of the number of bananas. Well, these are already both derivatives. So all I have to do here to find out if it's increasing or decreasing is compare g of 5 with f of 5. So all I got to do is compare those two guys. Now, when I compare those two guys, this guy right here is greater than. Okay, that's greater than. And you could get that by plugging both of those answers. Or what some people do is they subtract these two answers. And when I subtract those two answers, I get negative 2.263103, which is less than 0. So what would that mean? Well, that would mean the number of pounds of bananas. Remember, that's what we're talking about, right? The number of pounds of bananas. And when I look at their rates, they tell me if they're increasing or decreasing. And when I compare the two, okay, the number of pounds of bananas is decreasing. Okay, it's decreasing at that time. Why is it decreasing at that time? Ooh, I think I made a little bit of a boo-boo. When I do these, guys, and if I were to get negative, that means the amount that you're removing is greater than the amount that you are adding. So that is why the number of pounds of bananas is decreasing, and you have to make sure you say at time t=5. All right, now that was worth 2 points. And if you said G of 5 and you said F of 5, you got a point just for saying you were going to use those two. And understand that number of bananas and then increasing, decreasing means a derivative, and F of t and G of t are both rates. They're both derivatives of the total number of bananas. All right, now part D is the big bad boy, right? How many pounds of bananas are on the table? Well, it said that, is it up here? Yes, it is. It says that there's 50 pounds to start with. So here we go. Plus, so I don't even have to do a min or max for this problem. I just have to make sure I account for the amount of bananas. Okay, ooh, snap. Very interesting. Nobody starts adding bananas until after 3 hours after I'm open. So if it's t=8, okay, I add bananas from 3 to 8. Okay, so if you look very carefully, and if I take the antiderivative of that rate, that's going to give me the total amount of bananas that are on that display stand. But what else do I have to account for? Well, I've got to subtract from 0 to 8, right? Because people start taking bananas right when we open of the rate of people taking those bananas, right? We're removing those bananas. So this is going to give me the answer for the total amount of bananas that are on that display table at time t=8. And if I look at my answers, that gives me 23.347. Boom! That's how many bananas would be on the display table at t=8, right? And the reason why is because people are removing them. We don't start adding bananas to that until 3 hours in. That was worth 2 points. But I had to set up 2 separate intervals for that one. Why? Because we don't start adding bananas until 3 hours after we're open. Hopefully that was okay. Remember, hit pause on these guys. Oh, snap, look, you guys. We did 2018 first. We did 2017 next. And then they skipped a year of this. And then they went to 2015. All right, so let's look at 2015 here. All right, we're talking about rain that flows into a drain pipe. And it said it's modeled by this function, and it says cubic feet per hour. So this is a rate, very important to pay attention to, from 0 to 8. It says the pipe is partially blocked, allowing water to drain out the other end, which it's being modeled by D of t, and that also is a rate. There are 30 cubic feet of water in the pipe at time t=0. So there's my initial condition. First question that was asked. Okay, first question asked is how many cubic feet of rainwater flow into the pipe during the first 8 hours. So what the heck would I do on that guy? Well, R of t stands for the rainwater that flows into the pipe. So to do part A, it's just from 0 to 8 of R of t dt. Remember, all of these problems, very first thing you do is you should plug this guy in Y1, you should plug this guy into Y2. All right, and if I plug that in correctly, I get 2 points, right? These are always nice and easy Japanese problems. 76.570, yep, says right there, you would get 2 points for that. All right, now part B was real similar to the one we did in 2017. So do me a favor and hit pause. Is the amount of water in the pipe increasing or decreasing? Okay, this is asking if the amount of water, that's the total amount of water, and is it increasing or is it decreasing? Well, remember, just like the one we did in 2017, amount of water, increasing, decreasing, so the derivative, and these are both derivatives already because they're both rates. All right, so we've got the amount of water that flows in, and that would be given by R of 3. And if I subtract out the draining, right, but it's kind of blocked, right, but it's still draining, but it's going to be blocked, and that's going to be D of 3. Now, If you do R of 3, if you just compare them, you don't always have to do R of 3 minus D of 3. You just have to compare your two. But one way of comparing is by taking the difference. And for this, I got negative 0.313632, and that is less than 0. So what would that mean? Well, that would mean that R of 3 is less than D of 3. And if that is the case, then that means the amount of water in the pipe is decreasing when T equals 3. Okay, the amount of water in the pipe is decreasing at time T equals 3. Okay, and that was worth 2 points. If you showed that you were comparing R of 3 to D of 3, you got a point. And then you got the last point for that part by your answer and your reason. Okay, C and D. I'm hoping we're going to get like a min-max guy again. Oh, here we go. Part C. So this is the big one. This is worth 3 points. At what point in time is the water in the pipe at a minimum? Well, remember, I got to create a function. I'm going to call it W of T. That's the water that's in the pipe, the total amount of water. Now, remember, the total amount of water that is in that pipe is you got to account for your initial amount, which was 30 at time T equals 0. Okay, but then what am I going to do? I'm going to find the total amount, right? I'm going to do the total amount of the rate that water flows in to the drain pipe, which would be R of nu. I can't use T, so R of X. Now, remember that the pipe is partially blocked. So you got water entering and then you got water draining. So then I've got to subtract out the water that drains. So that's all I have to do. And that's going to go from 0 to T of dt. This is going to give me the total amount of water that's in the pipe. Now I want to know when it is at a minimum. And we all know to find a min, max, or extrema, what do? We take the derivative. Now, when I take the derivative of this guy, the derivative of 30 is 0, but the derivative of an antiderivative just means you got to plug that into both variables, R of t minus D of t. Okay, the 0, remember, when you have a constant and then take the derivative of a constant, you get 0. So we don't have to account for that, just the variable. But remember, whenever you take the derivative of an antiderivative, it could change. Here, the derivative of t is just 1, so it necessarily doesn't have a chain that we have to be worried about. Now remember, to find mins and maxes, we have to find critical points. So I want to know when the derivative is 0. Now for this particular problem, the derivative will be 0 whenever R of t is equal to D of t. And remember, I just have to focus from 0 to 8. So what should you do? Get out that sweet calculators, right? And you want to find out where R of t and D of t intersect. Well, we put that in y1, we put that in y2, and make sure we go from 0 to 8 in my window. And guess what? They intersect at t equals 3.271658. Booyah! But it does say to justify. And remember, when it says to justify, I've got to make a table. You got your time and you got the total amount of water that's in there, which means I got to account for the endpoints. I was really good, so I put this in alpha A. I stowed it, all right? And so I put it in A, and then I put these 3 values in for this. So it'd be 30 plus math niners, right? And you go from 0 to 0, which would be 30. You go from 0 to A, and if you did that, you get 27.964561. And then you go 0 to 8, which gives you 48.543686. This is obviously the minimum. All right, very surprising. Usually the max min question is the last question they ask. Make sure you hit pause. Make sure you go back and try it on your own. We have one more to go after this, which you're going to have to try on your own, but we got to answer D. What the heck is D asking about? It says the pipe can hold 50 cubic feet of water before it overflows. Remember, there's a blockage, so it could potentially overflow. For T greater than 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Right. But do not solve an equation involving one or more integrals that gives the time W when the pipe will begin to overflow. Whoa, what the heck is going on? How do I do this? Well, equation means there's going to be an equal sign. Okay, I can do that. And then once again, let's create something that stands for the total amount of water. 30 plus the integral, right, from 0 to, man, from 0 to what? Well, that's what we're trying to find. From 0 to what? Now, they want me to call it W when I overflow. So I'm going to go from 0 to W, and then I got the rainwater going in, and I got the drain pumping it out. Well, when the heck is that equal to 50? And when it equals 50, it overflows. How about that as an equation? What you could have done too is subtracted that 30 or made it equal to 20. Because when that is 20, you get 50. How about that? That would be worth 2 more points. All right, you guys, we got one last one to go. Don't want to make this too long, so maybe I'll fly through it. But even though I'm flying through it, guess what? Your job, come on, challenge yourself at home. Homie would want you to challenge. I'll bring them back to school. Make sure, remember, we went 2018, 2017, skip 2 years, bang. All right. So 2013, let me get my answers up here so we kind of fly through this guy. All right, let's see how we do here, you guys. All right, hit pause, please. Okay, by now you've probably unpaused. We're talking about unprocessed gravel. Okay, and we talk about a gravel processing plant. And unprocessed gravel arrives at that rate. So it's a rate. Okay, you have 500 tons that is unprocessed. Okay, from 0 to 8, when people are working, we process it at this rate, 100 tons per hour. That's another rate. So we're dealing with 2 rates. We got the rate that this gravel arrives, and we have the rate that we process the gravel. Okay, part A, G prime of 5. I just got to find it. What the what? So this is more important that, hey, it's kind of awesome because you get a point for getting the answer of negative 24.588 or 587, depending if you round or truncate, but then you have to explain it. Okay, they're making us explain it. And you should say at hour 5. Just take care of that. At hour 5, that's important. Now remember, you're taking the derivative of a rate. So that means I'm talking about the rate. So then you should say at hour 5, the rate, okay, that unprocessed gravel arrives is decreasing, right? Because I got a negative answer. Okay, so just make sure you talk about that. Since G of T is already a rate, it's talking about the rate that gravel is arriving. I just want to know if that rate itself is increasing or decreasing. That's why I took a derivative. So it's like a second derivative, right? This being the first derivative, and then the derivative of that would be the next guy. All right, and we would want to make sure we explain it correctly. All right, and make sure you do that, and it does. It says that this is in tons per hour, okay, which means this would be tons per hour. Remember, it was like one of those problems we did earlier in this little video lesson. All right, B, find the total amount of unprocessed gravel that arrives at the plant during the hours of operation. Well, the hours of operation are from 0 to 8. This is part B. And the unprocessed gravel is G of T dt. And remember, when you do the integral of a rate, it gives you the total amount, and that's what they're asking for. They even specifically say total amount, and if you got that correctly, you got 825.551 tons, the total amount of unprocessed gravel. All right, that's 2 more points, so we're up to 4 right now. Now we're into C, and then the more important question, which is D. Okay, so here we go, C. C says, is the amount of unprocessed gravel increasing or decreasing? Now remember, this amount of unprocessed gravel is the total amount. It's the total amount. So this means I'm dealing with derivatives. Well, if I'm dealing with derivatives, then what does that mean? That means I want to compare the derivative of the unprocessed gravel arriving with processing that gravel. Okay, and guess what I have to do? That just means I have to just compare G of 5 with 100 because it doesn't matter. We are always processing this at the constant rate of 100. And since G of 5 is less than, what would that mean? And you want to make sure you answer it correctly. Whoa, is that a long one? Boom. Okay. Munch. So the processed gravel, we're processing it faster. So what would that mean? The correct appropriate answer would be at time t equals 5. The rate at which the unprocessed gravel is arriving is less than the rate at which we process it. That's all you have to say. So then what does that mean? That means the amount of unprocessed gravel is decreasing, right? Because we're processing it faster than the unprocessed gravel is arriving. Bang, bang, choo, choo, train. All right, and that's considered by far the toughest part of these 4 questions. The most important part is the last one because it's worth ichi ni san, sanban, san points. It's asking me for a max of unprocessed gravel. So I'm going to count this U, unprocessed gravel. So let's call it U of T. Okay, well, do I have anything to start? I got 500 tons to start out. Whoa, is that a lot? Okay, and since it's a max or a min, I'm going to have to find a derivative. But first, I need an equation for the total amount of unprocessed gravel. And that will be plus the integral from 0 to T, because I'm trying to find out what is T? What gives me the max amount of gravel that's at this site? And that's just going to be G of T minus processing it, right? Because you got your unprocessed coming in, but then you're processing it. So that would lessen the load. 100. And remember, it's just 100 because it says 100 tons per hour. That's it. That's all I got to do. But remember, since this is a max min extrema problem, I'm going to take the derivative of that U, unprocessed gravel, and that would be the derivative of 500, which is 0, and the derivative, whoops, shame on me, exits. The derivative of an antiderivative means you just plug that in for the variables and set it equal to 0 to find my critical points, which my critical points would be whenever G of T equals 100. So what does that mean? Well, remember, shame on me. You plug that into Y1. Okay, you plug 100 into Y2. So you better be good at your window. Your window better have your T go from 0 to 8 or your X from 0 to 8. Okay, your window better go as high as 100. You got to go higher than 100. But when does G of T equal 100? Well, when T equals 4.92348. And remember, to get your answer, it's going to say to justify. Oh my gosh, this is the same on every test. So to justify it, I got T. I've got the total amount of unprocessed gravel, U of T, and my answer could be the endpoints 0 and 8, or alpha A, 4.92348. And what do I do with these? I plug these 3 into the unprocessed gravel. And if I do that, 500 plus 0 to 0 is 500. 500 plus math 9, right? Math 9, 0 to A, alpha A would be, my answer was 635.376. And then if I go from 0 to 8, the entire workday, it's 525. Oh no, we didn't work as hard as it was coming in. At the end of the day, you have even more, but the maths would happen at 4.92348 hours. Dunzo, that's it. Rates and integrate. Remember, if you want to get better and better, keep on looking for these problems. Or better yet, go back and try all of these bad boys from scratch and see if you can get them all right. That is how you will dominate this AP test. All right, class, aloha's, good luck.